All right, for 7.4, our learning target is to actually solve. So we've reached the point where we're going to start solving whatever type of equation is thrown at us. Maybe it will have exponents in it, maybe it will have radicals in it. We've seen some ones that we've had exponents in, like the quiz that you just took had an exponent in there. So what happens with radical equations? Those are ones that we have not tackled so far. We're going to skip over the warm-up just because we're pretty warm at this point, right? We've done quite a bit of math so far today already. So a radical equation, because we haven't seen one like this, it's an equation with a variable in the radicand. So the radicand is the part that's under the radical. So we have not seen equations like that before. We've seen exponential equations, but we have not seen radical equations yet. So what we want to do is we want to follow a very similar process that we've seen with exponents. We're going to isolate the radical on one side of the equal sign. Then we're going to raise each side of the equation to the nth power. And it's going to be dependent upon what your radical is. You might be raising it to a fraction power, or it might just be a whole number. It just depends on the question that I throw at you. As we go through this, we will see extraneous solutions. Meaning we will get a solution that when we go back and check it, it doesn't work out. So we have to check every question. And if I forget to check one, please just call me out on it because I want to make sure we check every single question we do today. If there is more than one radical, we might need to square both sides. And we're going to see kind of what that looks like. There are 8 examples in your notes. Well, there's 9 examples in your notes, but 8 of them I want to make sure we do. No skipping around. I want to make sure we do those first 8 examples because they're all slightly different. So let's just start right away by getting into it, okay? This is 2 times the cubed root of x minus 3. I know sometimes, especially, students can see a 2 cubed versus a cubed root. If you ever have a question like that, especially on a test, I know when they're side by side, it can be a little bit confusing. But I have the cubed root of x minus 3, that's times 2. I want to get rid of that 2. So what should I do? Divide by 2, right? Whatever I do to one side, I'm going to do to the other. So I get the cubed root of x minus 3 equals 2. Now, I want to get rid of that radical. So I want to do the inverse operation of taking the cubed root. So what's the inverse of taking the cubed root? Raising to the 3rd power. Exactly. We've seen this process before. It's just we only did it with square root. So now we do it both. So I get x minus 3 equals 8. Right? Just by doing that, we got rid of all that radical and exponent that we didn't want to deal with. Last but not least, we add our 3. We get x equals 11. And now I need to go back in and check it. So I do 2 times the cubed root of 11 minus 3 equals 4. 11 minus 3 is 8. What's the cubed root of 8? 2. 2 times 2 equals 4. You do not have to show all that work. If you're doing it in your head or you're using your calculator, you do not have to show every single step that way. Okay? Questions on our first example? Okay. Second example, how do I get rid of that 7? Divide by 7. So I get x to the 3/5 is equal to 8. Now this is a radical, it just happens to be written in exponential form. Any ideas on what I could raise it to make it just x equals? If I square it, I'm going to end up right, but when I raise a power to a power, what do? I multiply those 2 things. The reciprocal, you got it, Rowan. So I'm going to raise it to the reciprocal because 3/5 times 5/3 is just 1. So I end up with just x. But whatever I do to one side, right, I must do to the other side as well. So I get x equals 8 to the 5/3, which this is the cubed root of 8 to the 5th, 2 to the 5th. Yes, you can definitely use your calculator. I highly encourage you to use your calculator, right? There's going to be a lot of steps to these problems, so check your work that way. I plug this back into my original equation, which takes the 5th root of 32, which is 2, and then cubes it, which is 8. 8 times 7, 56. So that's when I say, when you go back and check it, you don't have to show me every step of the way, but you do have to mentally go back in and check it, or at least use the calculator to check it. All right, next example, right? All these examples are going to look slightly different as we go through. This part here is the radical. So what do I need to do first?
Isolate it.
Isolate it. Subtract the 3. X plus 2 to the 2/3 power equals 4. Now I raise it to the 3/2, right? I raise it to the reciprocal, just like we did on the other example. So the left side of my equation, x plus 2. We've got one little problem. I'm currently solving for x. This right here, this 4 to the 3/2, that means the square root of 4. When I'm solving for x, what's the square root of 4? Positive or negative 2. I have to consider both options. So what I really have here is positive or negative 2 cubed, which is positive or negative 8. And this is something that I know as you work through your homework, you're going to question it. When do I know if I have 2 answers? The easiest thing that I can say to remind you is whatever power you're raising to, if the denominator is even, this means that my nth root is even. So if you're raising to a whole number power, you don't have to worry about it. If you're raising to a fractional power, you do need to worry about it. Just take a step back and say, yep, I'm going to have 2 answers with this question. I'm not done, right? I need to do that whole, follow each path. I have positive 8 minus 2, 6. Negative 8 minus 2, negative 10. Those are my 2 answers. And we need to go back in and check that they both work. I know, this side of the room, why don't you check 6? This side of the room, why don't you check negative 10? Make sure you know how to type this in your calculator so you feel confident doing it. And type it in just like it looks, like for our negative 10 group. Negative 10 plus 2, notice it's in parentheses, caret, 2, 3, plus 3. If you have the black calculators, you probably don't need these parentheses for your exponent. For those gray calculators, you will need those parentheses. This side, does it work?
Yep.
That side, does it work?
No.
Perfect. We have 2 answers. Move on to the next page. So 3 examples down, 5 more to go. Well, our radical is all by itself on one side of the equal sign. So I don't need to move anything around. I can jump right to the next step, which is raising it to the power. What power should I raise it to? 2. Remember, right, there's a little implied 2 that is written there for square root. So I raise both sides to the 2nd power. Left side, x minus 6. What's my right side?
X squared plus 64 minus 60.
You guys are going to love it, right? This means this.
Oh my gosh.
Yep, there it is. I have to FOIL. Okay? I've got to FOIL all this out. Remember, if you have a binomial, that means you have 2 terms separated by either a plus or a minus sign. you're going to have to FOIL this out. I'll save us some trouble. I'll tell you what it is. There we go. All right, so we've already FOILed on this problem. Now I've got this whole algebraic equation. How do I solve this?
Add 6.
Add 6? Yep. What else should I do?
Add 16x.
Nope. I know you almost wanted to say it. I've got to set it equal to 0. Right? This is bringing us back to Unit 2. Factoring quadratics. Remember this whole, oh, right, I've got to think about my x marks the spot. Multiplies to give me 70, adds to give me negative 17. What two numbers do we have there?
10 and 7.
10 and 7, or negative 10, yes, negative 10, negative 7. So I factor it down. I then set each one of my factors equal to 0 and solve. I get x equals 10, x equals 7. Those are my two answers that I started with. All right, this side of the room, you check 10. This side of the room, you check 7. Let's double check that they actually work. You can do it in your head, you can do it on the calculator, you can write it out.
Yep.
10 work? Is the square root of 1 negative 1? No. So this one does not work. Our only solution is x equals 10. So here's just a little tip. When you start your equation, so when you first look at your equation, if you have an x on both sides of the equal sign, it is more likely that you will run into an extraneous solution as you solve. So just kind of think of that like, oh, there's an x on both sides, bing, I might have an issue when I get to the end. You still have to solve it the same way, it's just you have to double check those answers. Questions on that one? All right, number 5. Oh, looking crazy. Well, I've got a radical on one side. Well, I've got two radicals on this side. Can I add these together? No. They're both the fourth root, but I can't simplify them down by just adding. So here's the problem. If I raise this to the 4th power, I have to FOIL this out 4 times because there's a plus sign in the middle. Yeah, we don't want to do that, right? We want to try to find a shortcut. So here's what we're going to do. We're going to move one of these, doesn't really matter which one, over to the other side of the equal sign. So I'm going to subtract the 4th root of 2x from both sides. So I get the 4th root of 3x minus 2 equals negative 4th root of 2x. Now I want to raise both sides to the 4th power. So I raise both sides to the 4th power, which is great, right? That's going to cancel out my 4th root. So on the left-hand side, I get 3x minus 2. On the right-hand side, now I have a negative times a negative times a negative times a negative. So it becomes positive. So I just wind up with the fourth root, oh sorry, not the fourth root, just 2x. And not just raise the 4?
Yeah.
Okay, let me show you a little side here. What does that mean? X plus 2 plus x plus 2 plus times x plus 2 times x plus 2, right? I have to multiply it 4 times. So all I've really done is instead of this being x, it's the fourth root of 3x minus 2. And instead of this being 2, it's the fourth root of 2x. That binomial situation really messes up that idea. Technically, mathematically, if we were all supercomputers and our heads could do that, you can do that. It's just going to take way too much time to solve it that way.
Thank you.
Yep. All right, at least here, right, we get down to just a two-step equation. Right, I move my x's to one side, divide by -1. I get x is equal to 2. So I get down to my answer pretty quickly, at least using that approach of putting one radical on one side, the other radical on the other. Now the trick is, if I check this, they're not going to work out to be nice round numbers, right? So far, I've made sure that the problems that we've had have worked out to nice round numbers. I get the fourth root of 3 times 2 minus 2 plus the fourth root of 2 times 2 equals 0. So I get the fourth root of 4 plus the fourth root of 4 equals 0. Now I don't know what the fourth root of 4 is, right? It's some decimal number. We've got a positive decimal number plus another positive decimal number. Can that ever equal 0?
Yeah.
No. Right? A positive plus a positive is equal to 0. This can never happen. You can put it in your calculator, right? So unfortunately, I know after all is said and done, the answer to this problem is no solution. Questions so far? I know, I was waiting for the... All right, let's look at 6, 7, and 8. Start with number 6. We've got our radical on one side and our radical and no radical on the other. What are we thinking? What's the approach? Raise everything to the third power.
Is there any other way?
Oh, please tell me there's another way.
Unfortunately, there is no other way, but I'll cube it for you. I'll tell you what the value is so we don't have to all spend our time doing it today. The cubed root of x plus 5 raised to the third power, that's all nice and pretty. This one, there is no faster way to do it other than to FOIL and then FOIL and then FOIL.
But we love doing that.
We love to FOIL, don't we? I'll write it down for you. I've FOILed it out for us. We've got to multiply, right? If we were doing this ourselves, we would FOIL these together, and then we would distribute everything through to the x minus 1. I still have that x plus 5 here. So this brings us back to last unit. Last unit, how did we solve polynomials like this that had a cube in there? We grouped it, right? But before I group it, I've got to set it equal to 0. I've got to do that same approach that we did before. So I get x cubed minus 3x squared plus 2x minus 6. Now I can go ahead and group my front and my back, take out my GCF in both locations, make sure that when I do that, I wind up with the exact same factor, right? The x minus 3 factor is the same. So I get that x minus 3, x x squared plus 2. Well, x minus 3, that's going to have a nice round answer, right? X minus 3 equals 0. I get x equals 3. Perfect. This one over here, imaginary. And for this unit, just like last unit, all you have to do is identify that it's not a real solution. You can stop right there. The only solution we have here is x equals 3.
And then we get to find out.
Then we get to find out, is it really real? Does it really work out?
It does.
It does, because the cubed root of 8
It's 2.
is 2. Right? For most of these, especially, I try my best to make sure the answers are nice round most of the time. You can probably do this in your head rather than relying on a calculator. Because I know sometimes the hardest part is how do I plug this in the calculator the way it works or the way it looks in the problem itself. Questions on that one? Am I going too fast? You guys okay? 2 more problems to go. Also both a little different. So I've got a radical on one side, a radical on the other. I would easily just square this, and I just have to remember that this is also going to have to be squared. I can't just choose to only square part of one side of the equation. I have to square both sides of the equation. So when I do that, remember, we're multiplying between here. So since I'm multiplying between the 4 and the radical, I can bring the 2 in, right? I can use that exponent rule. So I get 16 times x minus 2. Notice it's the quantity x minus 2 equals x plus 13. And I say that like just reminding us that that would necessarily be the quantity, because this is gonna make it a multi-step problem, right? I've got to distribute before I move my x's around. I get 16x minus 32 equals x plus 13. Add my 32, subtract my x. I get 15x equals 45. X equals 3. Plug it back in. 4 times the square root of 1 is just 4. The square root of 16 is 4. It checks out. Last example on a Friday afternoon. This one here. And I just want to do this example. It's very similar to one we've already done. I think it was example 3. I really just want to do this one because it's another example of when we get 2 answers, when we have to remember to put in plus or minus as we're doing this. So I add my 9 to both sides. I get the quantity x minus 4 to the 2/3 equals 25. I raise it to the reciprocal. And because that power that I'm raising it to has an even denominator, that's when I get x minus 4 equals positive or negative 5 cubed, right? When I took the square root of 25, I had to put in positive or negative. So I get x minus 4 equals positive or negative 125. Add 4. X equals positive 125 plus 4. 129. X equals negative 125 plus 4. Negative 121. So don't forget that step either. And then we plug it in to double check. How about you guys just take me for my word? They both work. You guys have checked every single one so far. All right, we don't have to do example 9 in your notes. If you want to, you can go ahead. Your homework is that 7.4 worksheet. Let me know when you have questions. You did excellent work today.
Do we need to review them by next time?
No, so on Wednesday, we will spend the whole class reviewing. So the review worksheet will be homework that day. So I'll have a review worksheet. I'm gonna see if I can find a GIM kit for us to do, or would you prefer not? I don't know, you guys tell me what you like. I'll make sure we have enough stuff to review on Wednesday that we're ready for the test on Friday.